Sedimentary rocks. Can we date sedimentary rocks using radiometric dating? The answer traditionally has been no. The reason is because the minerals that are found in a sedimentary rock are eroded from previous rocks. But geologists still are interested in where the sediments came from. So there are crystals, minerals inside sedimentary rocks that they use radiometric methods on, but that's sort of to date the source rock, sort of try and find out where the material was eroded from. In recent years, they've started to look at, because what happens is when the sediment dries out, the chemicals in the water provide the cement and bonding agent that binds the grains together to make the hard rock. And so if you sample the cement, that cement has formed at the time the sedimentary rock is formed. And they are starting to apply the radiometric dating methods to that to try and date the sedimentary rocks. But typically, sedimentary rocks are dated according to their context and also the fossils that are in them. Not that the fossils, it's a tricky business because ages have been assigned to the fossils relative to their position in the strata record according to their sequence in terms of evolution. But also they've gone in and seen, well, there's this volcanic ash bed between this fossil layer and this fossil layer here. There's two volcanic ash beds either side of this fossil layer that's got a sedimentary fossil layer. So they'll use the radiometric dating methods on those volcanic rock units and therefore assign an age to the fossil and the sedimentary rock between. And so they indirectly have therefore dated the fossils and the sedimentary rocks by using the radiometric methods. And so we need to understand that that's the process. It did start off in a less involvement with radiometric dating, but increasingly radiometric dating is being applied. Now, when we're talking about radiometric dating, we're talking about methods like uranium decaying to lead, potassium to argon, rubidium to strontium. These are what we call long age methods because uranium decays very slowly today to lead. Potassium has a half-life, so if you start with a pound of potassium or a kilogram, within one half-life you'll have half that amount left, and that time is over 1 billion years. And so it takes a long time for potassium decay to argon. And so they assume that decay rate has been a constant. They assume, as we said before, they know the starting conditions, and they assume that there's been no contamination or material coming in or out. Well, water's been involved. We know that water will leach things and water will transport things. So there are problems with all of those assumptions. But many people think that carbon dating is being used to date rocks and fossils. The answer is no. It's not routinely used. Why? Because radiocarbon, decays very rapidly back to nitrogen, and we've calculated it by measurements. About 5,730 years is approximately the half-life. So if you start with a kilogram or pound of radiocarbon, within 5,730 years, half of it will have decayed away. Whereas uranium, it's 4.5 billion years. It's a big difference. So, therefore, if you believe that the rocks and the fossils are billions of years old, millions and billions of years old, you won't use radiocarbon because you'll say, the radiocarbon will have all decayed away. There shouldn't be any left. The interesting thing is that they wanted to, when they established their radiocarbon dating laboratories, they wanted to get a background measurement. Okay, you've got to know whether you're getting contamination in your laboratory, for example. Cosmic radiation actually is what produces radiocarbon, and so there's background cosmic ray interaction, and so you want to use a material that you think has no radiocarbon in it and test it when you compare it to a sample that you want to test for radiocarbon. The interesting thing is throughout the 1980s, when they were starting to use more sophisticated methods for using radiocarbon, they were doing this in the laboratory, and they were discovering they took coal, they took limestone, they took bones that they thought from fossils that were millions of years old. They should have no radiocarbon in them. What did they find? Every sample they tested had radiocarbon in them. And so they said, we've got a problem here. This now limits how far back we've got this contamination. It must be a machine or it must be in the laboratory. Let's that puts a limit on radiocarbon. And most laboratories will tell you now that the limit to radiocarbon is about 55,000 years. You can't go any further, even though the equipment they use can theoretically go back 95,000 years. Well, we have actually said, well, wait a minute, what if these materials are young, as the Bible says they are? If these are fossils, say dinosaurs, which were wiped out during the flood 4,500 years ago, there ought to be radiocarbon still left in them. And so, for example, I went around and I collected fossil wood samples from various places. I went to England, in fact, and got samples from a known deposit where there was other marine fossils, but there was wood with it. I've been to other parts of the world and got samples, and every one of them, even though they're supposedly millions of years coal, millions of years old, have radiocarbon in them. In fact, many of them have a similar amount of radiocarbon in them. And that means, for example, we took 6 coal samples from different coal beds in the United States that were from 300 million years old, supposedly up to about 40 million years old, and they all had the same amount of radiocarbon in them. They all dated to about 48,500 years. That's radiocarbon years, assuming constant rate of decay and making a lot of assumptions. But that means that all the vegetation in those coal beds must have lived and died at the same time to all give the same radiocarbon age in these coal beds. But wait a minute, that's exactly what the Bible says. These trees were living, they got wiped out by the flood, they all should have the same age because they all those coal beds formed during the flood, which is 1 calendar year, 4,500 years ago. And so that was astounding evidence, as it were, that was consistent with what the Bible says about the flood. Now, of course, the Earth's magnetic field affects the production of radiocarbon. The Earth's magnetic field forms a shield that protects the Earth from cosmic radiation. There's evidence the Earth's magnetic field was stronger in the past, which would cut down the rate of radiocarbon production, which means that there was potentially less being produced earlier in Earth history, which means if we assume the present rate of production, the present rate of cosmic rays today, to calculate those ages, we're going to get overinflated ages. As soon as you start to make corrections, those ages shrink down from 48,500 years down to 4,500 years. So radiocarbon, even the archaeologists admit that there's problems, because if you go back and look at some of the archaeological materials that can be dated according to the historical context, according to the development of writing that you get from written records, etc. You go back about 1000 BC and radiocarbon matches. But as soon as you start going back beyond that, the radiocarbon ages get older and older compared to the known historical ages. In other words, something was different in the past, and we say, yes, the Earth's magnetic field was stronger in the past, therefore the production of radiocarbon was less, and so we're over-calculating the radiocarbon ages. And that's well documented in the literature.